Welcome to tonight's video on Unit 11, Part 2, talking about the area of a trapezoid, a rhombus, and a kite. So, in order to find the area of a trapezoid, it's equal to 1/2 the height times the sum of the bases. Because remember, in a trapezoid, the two bases will be of unequal lengths. So, for example, it says find the area of steel used to make the side of a razor blade shown below. So the height is 1, and the two bases are 3 centimeters and 2.5. So the area is equal to 1/2 of 1 times 3 plus 2.5. So it's equal to 1/2 of 5.5, which is equal to 2.75 square centimeters. So here, Miguel designed a deck shaped like the trapezoid below. Find the area of the deck. Well, first we'd have to find the length of this base up here. So if we divided the figure into a triangle and a rectangle, so first of all, this would be 4, which means if you did the Pythagorean theorem, this right triangle would be 3 right here, because x squared plus 4 squared equals 5 squared. That means x is going to equal 3 when you solve it. It's also a 3, 4, 5 Pythagorean triple. And if this is 3 and the whole thing is 9, that means this is 6, which means the top is 6. So the area of the trapezoid is equal to 1/2 the height, which is 4, times the sum of the bases, which is 9 plus 6. So 1/2 times 4 times 15. So it's half of 60, which is 30 square feet. All right, then Ramon is carpeting a room shaped like a trapezoid shown, where the bases of the trapezoid are perpendicular to the 8-foot leg. So that means right angles. Find the area of carpet needed. Well, we're going to have to do the same thing to find the top leg or top base. So here it's 8. So if we do 8 squared plus x squared equals 10 squared, you're going to get x equals 6. So this is 6, which means this is 8. So then the top here is 8. So if you find the area of the trapezoid, it's 1/2 of 8, which is the height, times 8 plus 14. So 4 times 22 is 88 square feet. All right, to find the area of a kite or a rhombus, they are both the same. The area of a kite of a rhombus is 1/2 the product of the diagonals. So you have to go 1/2 diagonal 1 times diagonal 2. So for example, if you want to find the area here of this kite, one diagonal is 9 feet, the other is 13 feet. So you go area is equal to 1/2 of 9 times 13. So 9 times 13 is 117. So half of 117 is 58.5 square feet. The next one, the area is 1/2 of 7 times 12. So it's 1/2 of 84, which is 42 square feet. Here it says find the area. Now this is a parallelogram. Or sorry, this is a rhombus. Now notice this is 9, and then this is 10 and 10. And remember, in a rhombus, the diagonals are perpendicular. But remember also, in a rhombus, the area is 1/2 of, the whole diagonal here is 18, times 20, which is the other whole diagonal. So it's equal to 9 times 20, which is 180 square inches. So in this next one, same thing. This is 7, this is 9. So the first diagonal is 14. The second diagonal is 18. So it's going to be 7 times 18, which is 126 square inches. So one diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 64 square inches, what are the lengths of the diagonals? So 64 is equal to 1/2, and then it's diagonal 1 times. So basically, if we let x equal diagonal 1, then 1/2, then 2x could equal diagonal 2. So since it's half as long, or 1 is twice the other, so basically we have 1/2 of x times 2x. So 64 is equal to, well, half of 2 is 1, so x times x is x squared. And then the square root gives you 8. So diagonal 1 is 8. And diagonal 2 would be 16, because it's 2 times it. All right, trapezoid QRST has an area of 210 square yards. Find the height. So remember, area is equal to 1/2 the height times the sum of the bases, which are 20 and 50. So since it's 1/2 here, we will go 210 equals 1/2 the height times 70. Well, half of 70 is 35. So it's 35h. So then divided by 35. And h is equal to 6. So the height is 6 yards. All right, so to summarize, the area formulas are listed below for the polygons, for the parallelogram, for the triangles, for the trapezoid, and for the rhombus and kite. All right, next we will talk about area of circles and sectors, coming up in part 3.